Hi everybody, I'm Malvika, and today we're excited to explore ways audio, image, and video can come together to build groundbreaking multimodal applications. Today we have customers from Hilo and WPP to show this impact in real time. And to kick things off, I'm so excited to announce the release of Sora coming soon to public preview on AI Foundry.
Hello, my name is Don Scott. Welcome to this showcase of Sora, a groundbreaking video generation model now available on Azure OpenAI. Sora, with its robust trust framework, comprehensive API, and video platform, are attractive to enterprises and individual artists alike. Imagine reducing the production time for professional quality videos or B-roll down to mere minutes. Let's dive in. Azure AI Foundry now features a dedicated video playground for generating videos powered by models like Sora. This interactive environment enables you to begin your creative process efficiently. Whether you're experimenting with new ideas or refining a video concept, the playground is your gateway to where it all happens. You can integrate Sora's video generation capabilities directly into your applications for seamless creativity. The Sora API from Azure OpenAI Service lets you dynamically integrate the model outside of the playground environment. This empowers your teams and your customers to use this API in their own creative workflows. With just a few lines of code, teams can produce videos that are compelling. Imagine you're a creative lead at a marketing firm tasked with crafting diverse ad campaigns for your clients. You're tech savvy, so you want to quickly script out a couple of ideas. This is where the API comes in. Here's how simple it is. You provide a text prompt, specify your video's desired length, resolution, and variations, and Sora takes care of the rest. Let's walk through a couple of scenarios where Sora can elevate your creative outputs. First, a luxury perfume brand aiming to launch a new fragrance. We use Sora to generate a beautiful commercial, offering a glimpse of the fragrance's versatility. Next, let's explore how Sora uplevels the employee experience in the manufacturing sector. You can enhance safety training from narrated presentations to videos that actively show employees wearing protective gear and following protocols. This approach not only makes training more engaging, but also promotes worker safety. Finally, a film studio wants to create a new movie featuring a fluffy monster. Using Sora, we generate scenes where the monster discovers an old typewriter and becomes a celebrated novelist. These storyboards are not only fun, they help visualize potential scenes for production conversations, aiding creativity. Now, let's explore another exciting application of Sora with a focus on the gaming industry. Imagine you're tasked with enhancing the marketing campaign for an upcoming Xbox game. Using Sora, you generate dynamic video trailers that simulate thrilling gameplay moments and key features of the game. We've only scratched the surface of what's possible with the Sora video generation model on Azure OpenAI Service. From all the use cases we've shared, the potential for custom applications are vast. Try Sora today.
As you just saw, AI is no longer just about text. Today, AI doesn't just understand words, but it understands context, visions, and motion. With models like GPT-4 Audio and GPT-Image1 in Sora, you can generate entire advertising campaigns with just a few lines of input text. In many ways, the rise of multimodal AI today is comparable to the inception of photography in the 19th century, introducing a new creative medium that didn't replace painting, but expanded the boundaries of artistic expression. Today, we're introducing audio, image, and video models to Azure Foundry to bring that vision to life. Together, through sound and motion, these models tell stories, all through APIs. We recently released our most cutting-edge audio models for speech-to-text and text-to-speech. For the first time, you not only understand what's being said, but how it's being said, translating vocal tone into actionable sentiment data, a powerful tool for customer support where the humanization of AI is really pivotal. Reliable and accurate, these speech-to-text models can capture the nuances of speech and expand the possibilities of voice-based interaction. To further demonstrate the impact of these innovations, I'm so excited to introduce Sid Shah, VP of Strategy and Growth at Helo, to speak on ways Helo is freeing up clinical staff from routine tasks and improving patient experiences at scale. And before I get started, I'd love to introduce this customer video on Helo.
Hi, I'd like to book an appointment with my primary care doctor.
You got it.
When patients require medical attention, they expect quick and accurate responses.
Rocky Langdon.
Doctors' offices are getting up to 50 million patient communications a month. Their staff is overwhelmed. At Helo, we are automating some of these interactions to free up healthcare staff to focus on patients that are in office. Helo Genie is an automated contact center, so patients get a response quickly from the AI solution.
Sid Shah.
It was crucial for patients to be able to interact with Genie in the way they communicate with anyone.
Bharat Satyanarayana.
So we built Genie using Azure OpenAI in Foundry models because it enables interaction across voice, video, and chat. We have also been previewing GPT-4o real-time API audio models, enabling faster
In a
responses.
car, on a smartphone.
Hello?
Hello, Priya. I'm calling to confirm your MRI appointment. Do you have any questions?
Can I eat my breakfast before the MRI?
Yes, you may eat and drink as usual.
With private medical information, we need to ensure that the data is highly secure to support compliance with regulations like HIPAA. Azure provides tools and services to maintain compliance and build responsible AI
A
applications.
smiling patient.
Provision throughput units help us to provide consistent, reliable performance and predictable costs.
Thanks to the scalability and security we get with Azure, Genie allows healthcare staffs to dedicate their time to what truly matters, which is patient care.
A patient and his doctor. Microsoft.
Thank you, everyone. My name is Sid Shah, and I'm the Vice President of Helo. We're a healthcare technology company based out of Massachusetts, and we have customers which are physician practices. We also have payers and PBMs as our customers, and we offer the software solutions for these customers of ours to engage better with their patients and members. We build software which encompasses the journey of a patient when they go visit a doctor, right? Everything that happens before the visit, during the visit, and after the visit. Imagine things like, booking an appointment, registering for, at the doctor's office, checking into a visit that you have, things that happen during the visit, like the notes that the doctor create. We have a ambient listening product that we just released last year, which allows the doctor and the patient communication to be automatically transcribed and summarized and made available in a summarized structured note, so the doctors don't have to spend time in building those notes. And everything that happens after the visit, like making payments or communicating with the patients, for healthcare reminders and alerts. So Helo provides, software solutions between, these visit before, after, and during the visit. To give you an idea of the footprint, this gives you some statistics, some numbers. We touch about 16,000 different physician practices, 180,000 providers, physicians that use the product, and their patients have access to the medical records through Helo mobile app. We send communication messages out to patients through different channels like voice, text, emails, and we do about 50 million of these every month. Our payment processing solution processes about $2 billion worth of payments every year, and we connect with the top payers, PBMs today to kind of help them through connection between their members and them. So as you see, we have a good amount of users in the US. We've used AI. We've been using AI for quite some time now. We started our journey right when it was announced, starting I think January 2023. We started to adopt this in different places, and we do have the different models that we use today for image, text, and voice. To give you an idea of the different use cases that happen in healthcare, I won't be able to cover all of these. It'll take the full session, but I'll touch upon some of them. Document management is one of an area which you can probably relate to. doctor's office use faxes all the time. It's ironic we're talking about AI and then we're talking about faxing, right? But it's being used every day at every physician practice. They get tons of faxes from different places, other doctor's office or from patients and so on, labs and other places. So when these documents come into the doctor's office, somebody has to, it's the full-time role of a person to take those documents and file them in the patient record in the right folder and then assign it to a person who can then review it. With the option of the Image AI, we're able to actually sweep through those documents, file them in the right patient record. If you have a fax that is multiple pages, we can take away and break those pages down and file specific pages to different patient records, put them in the right folders, assign it to the right user, right? So it saves a lot of time for practice staff. It also helps with reducing the error rates, which happens when you manually file these records. So that helps a lot in these use cases. I mentioned about Suno also, right, a little bit, which is the ambient listing product, and that saves a ton of time for physicians because they don't have to go point and click and document their chart, right? The ambient listing system is listening to the provider-patient discussion, and it converts that natural language into a clinical note, which the doctors can just put into their system, and it's available to use. So it takes away the burden from physicians. Hilo Genie is the product I want to talk about next, which is a AI-powered contact center solution. It sits on top of EHRs and CRM solutions, and it's designed to help physician practices improve their operations and reduce the burden on the staff. So what happens today is, when phone calls and text messages and chats come from patients, the doctor's office are overwhelmed right now. They maybe don't have enough staff. To take those many number of calls, it takes a lot of people to manage that. With this product of ours, we offer an agent to our physician practices, which will take these calls and routine tasks like appointment booking, refill requests, billing questions, referral questions are all addressed through this agent. And if the agent is, for whatever reason, not able to answer or the patient needs to talk to a human, we also route these calls through our contact center solution to the human agent. We don't stop there. When the human agent takes these calls, we also assist the human agent through AI so they can shorten the amount of time they take to get the patients the answer to the questions they have. We also have this Genie agent help the patient practice during after hours. Patients call, let's say after 6 o'clock when the doctor's office is shut. Genie will collect the information that the doctor's office would need and then route that information to the on-call provider. So now they don't need to buy separate systems or have a autoresponder or someone to take that information. So it saves them a lot of cost. And then finally, we also have conversational smart campaigns. So there are many routine reasons why physician offices call the patients. For example, if there's a procedure, I need to call you to prep you for the procedure. I need to call you for an appointment reminder. We need to call patients for routine follow-ups, right? So there are many various different reasons why practices call the patients. What we're doing now with Genie is we're making that conversation happen through the AI agent, right? So it's it takes away the time from a physician office to make those outbound calls. Genie will make those calls for the practice. So as you can understand, there's so many different use cases, and it'll free up time from the physician office and to really take care of the patients. Here's just a quick kind of a snapshot of the architecture of this product. As you can see, on the left side, you have the patient who can call, text, or come through the practice website through a chatbot. We use Azure Communication Services to route that information. The function app in the middle will take the event, transfer past that to the FAST API, and that will connect to the EHR or a CRM tool, get the right information back, understand the intent of what the patient's trying to ask, use the Azure OpenAI models to get the answers, and then respond back to the patient. Works beautifully, and thank you to our friends at Microsoft and the Azure team to help us with this product. Thank you.
Thanks, Sid, for the awesome presentation. It was super cool to learn about Genie and the way that you guys are leveraging multimodal AI. Now, to shift gears a little bit, I want to dive a little bit deeper into image and video and how that's unlocking new dimensions of creativity. We recently released our new image models with video coming soon onto Azure OpenAI Service. And what makes these models especially powerful on Azure is the enterprise-grade foundation that they run on. You get billing, network, identity, and first-party infrastructure all in one place, which is huge when you're deploying at scale. We also have these models available through APIs, which means that they can be easily integrated into your workflows. They're responsible by design with C2PA, provenance, and abuse monitoring, so enterprises can deploy with confidence. And we also have an image and video playground for those wanting to iterate and compare the different outputs of models as part of our larger Foundry model ecosystem. So now I want to dive a little bit deeper into GPT Image 1. The viral ChatGPT model was released as an API a little bit less than a month ago. And this builds upon the strengths of its predecessor, DALL-E, but has significant improvements. What's most compelling to customers today is its multimodal flexibility. It not only takes in text as input, but image as well, also offering in-painting and text transformation. The text rendering in particular is really valuable for education and e-learning platforms, so they can render text along with images for storybook generation. The 1024 plus pixel support is really good for professional applications, expanding the possibilities and the different use cases. For example, gaming studios can leverage GPT Image 1 for character design, particularly for RPGs, which require rapid iteration during prototyping. And retail customers no longer have to rely on expensive photography or equipment, and they can visualize listings. And lastly, for advertisement and marketing, where the main focus is storytelling, you can generate visuals and pitch books tailored to your particular use case and brand. The same creative velocity that we're seeing in image, we're also beginning to see in video as well. Which brings me to Sora. For customers like WPP, the ability to easily visualize big ideas in video has long been a bottleneck, leaving bigger ideas more difficult to pitch and abandoned way too soon. Sora addresses this problem head-on. It's a flexible, high-fidelity video generation model capable of generating up to 20 seconds of video and 1080p in resolution. We offer text-to-video with image-to-video coming soon as a fast follow, and it's accessible through our API and intuitive video playground. There's diverse applications for Sora. If you want to showcase brand responsibility, you can visualize supply chain journeys. For e-learning and education, you can generate 2 to 3 second clips showing how protein is created, and you can also generate stunning visuals that attract visitors from all over the world for travel and lifestyle. But what truly sets apart Sora is how accessible and scalable it is. Unlike many video models today, Sora in Azure OpenAI is available as an API. So you can embed video generation directly into your creative pipelines. So let's take a look at the actual API shape and how it works. The video generation in the Sora API is job-based, so you submit a prompt and config through the video generation's job endpoint, and then you can easily pull the status by passing in the job ID. And finally, you can retrieve the video by passing in the generation ID. Overall, the API is great for asynchronous tasks, and we partnered really closely with WPP in our early access program, who leverage the Sora API in the video playground. And I truly think that customers like WPP are really innovating the way that they interact with end users and consumers today. Which leads me to the second half of our session. So I've talked a lot about the what and the why of multimodal AI, but I'm really excited to introduce Tasmika, who will actually show you how you can go from iteration into actually building these multimodal applications in real time.
Thanks, Mel, and thanks eClinicalWorks for an amazing demo. Now that we know the what in terms of the amazing model capabilities and API contracts, and we saw a lived example on how to scale up your architecture, let's talk about the how. How can Azure AI Foundry help you accelerate your inner development loop, specifically when it comes to multimodal models, and when you're considering planning, experimentation, and portability to code? Such a great specific question. I'm so glad that you asked. As multimodal developers, we know that speed and clarity means everything to us, especially when we're working with highly visual models that often require multiple iterations at a time to get it just right for our use case relative to prompt adherence and generation controls. Even more so when we're wanting to go from idea to V0 as a prototype to V1 in code really quickly, and save us time to build resilient systems later on. We also know that multimodal models sets the foundation for multimodal agents, and the promise and the dream of multimodal agents is a single unified pipeline across the enterprise that allows for multiple data input formats and enables us to extract, transform, and act on our information across disparate silos in the enterprise. That's the dream. How do we get there? Azure AI Foundry supports every step of the agentic software development lifecycle in 4 main stages: planning, developing, adapting, and operating. Within planning, you're able to access the same models that we just talked about as serverless API endpoints through the Foundry Model Catalog, which means rapid prototyping, version-aware access in an industry that changes daily, and quicker time to build composable modular workflows when you're thinking about agent and model chaining, without the complexity of GPU management, specifically when we know that these multimodal models often require a single node of A100 or H100 with IB if we're lucky, in order to scale for our products and our services. Also within the planning stage is the playground. We're going to spend some more time talking about that today. Think of this playground as your technical UX sketchpad. You're able to assess real-time model efficacy with your team and other collaborators done in a trustworthy and compliant way. From the playground, you're also able to port to code. And once you're in your chosen IDE, we're going to hope that you say VS Code, you can continue to build and customize your agent and model pipelines and run various API operations from your own models, the Foundry SDK, and other ISV products that you're using. From there, you can switch on tracing to enable continuous iteration. And once you're in a production state, you can also, of course, enable real-time monitoring and data analysis to ensure scalability and efficiency of your workload. In the context of multimodal models, let's double-click into the inner development lifecycle, specifically for the models that we just spoke about. How can we achieve that in Foundry? Modern development with multimodal models often means that you are developing against a rapid set of growing APIs, data formats, pre- and post-processing logic, and also runtime dependencies. That's what you're engineering against all the time. Before committing to a full integration, you as a developer need a safe, controlled environment to quickly validate model behavior and intermodal dependencies. Whether you're chaining an image for image captioning in an LLM, or you're using semantic search with a video model, for example, early exploration is critical as part of that. And as multimodal pipelines and the software ecosystem continues to increase in complexity, the need for a safe, lightweight environment to continue prototyping and avoid over-engineering early becomes critical so that you can spend more time building resilient systems later on. The Foundry Playground was built to meet this need, to help you reduce costs of experimentation, iterate faster, optimize your prompts, and go to code quicker. Think of the playground as your technical sketchpad in a controlled UX environment that enables you to experiment with your prompts, evaluate model consistency relative to prompt adherence, and also optimize your outputs for industry use cases. What you're seeing right there is the new image playground that we just released. The benefits of the playground lies in a reduced cost of experimentation. In traditional workflows, experimentation can be quite expensive. We have to set up scaffolding code and builds and so on. And we're also doing it in a very isolated way. We're sending something to localhost, and we're not thinking about how can this be compliant, trustworthy, and safe, and how can I collaborate quicker with my team. The playground is here to hopefully change your dynamic there. You can experiment with text prompts, adjust your various generation controls, and explore editing variations, all supported by native model API support. So whatever model that you select is naturally reflected within the playground. You can validate the API behavior, test edge cases, and expect responses directly in a very interactive console. You're able to debug and tune prompts and build your own prompt variations available in the playground, grounded in model behavior. And of course, you have access to multilingual code samples that represent per generation, and you can easily port that to your IDE of choice. Tactically, the playground helps us answer questions like, how is my endpoint going to behave in edge cases? What's the minimal prompt that I need to get the output that I want? How does model latency change if I'm adjusting some generation controls or if I'm enabling chaining? And finally, what model provides the best price to performance ratio before I turn this into an agent? 20 days ago, we released the Images Playground 2.0 into public preview. We're very excited about it. It supports GPT Image 1, which we were just speaking about earlier from Azure OpenAI. It also supports Stable Diffusion 3.5 Large, Stable Image Core, Stable Image Ultra from Stability AI. And we're very excited. You may have seen it in Satya's keynote. Flux 1.1 Pro is coming to Azure from Black Forest Labs, and Image Playground support will be available from day one access as well. We're also very excited to announce the Video Playground in Azure AI Foundry is coming very soon to public preview specifically for Sora as its very first text-to-video generation model. We're thrilled about this. I think you will be able to go from prompts to playback very quickly. So let's see it in action. I'm an AI developer at an e-learning company that educates a global student base about astrophysics and quantum computing. We build highly interactive tutorials and learning aids, and I want to see if Sora is going to be a good fit for my use case. I've heard about it from Azure AI Foundry models. So what I do is I navigate to the Azure AI Foundry homepage. I can see the various projects and resources available for me, and I can also have the opportunity to explore other models and capabilities. And if I scroll down, I can see other models that are available to me, including the opportunity to go and navigate to the Video Playground. I see the banner, and I click the button, and I'm taken to the Video Playground. And when I'm in the Video Playground, I see the pre-built prompts page from Microsoft, which showcases curated videos selected by Microsoft to inspire me on what is possible with Sora for my industry use case. These are stunning videos, and they cover a variety of different industries. When I hover on a video, I see a slight black backwash, and I'm also able to see the prompt and the model that was used for generation. In this case, it's a quantum computing circuit board. This is a consistent experience, and when I hover in other videos, I can see it as well. I'm also able to pause videos. When I click on a video, I'm taken to the lightbox effect, which opens up my video in full screen. I can see the prompt, I can see the playback button. I'm able to pause the video and restart it. And in the top right corner, I can see the view code button. I can download the video to local as an MP4 file. And I can also see the information generation tag, which tells me the prompt, model, duration, and other generation controls that were used for my video. I can copy the prompt from the generation information tag for further use later on. I click out, and because the lightbox effect is a carousel, I can easily flick through other curated videos available that Microsoft has made. Like this amazing video of a lion. I love the granularity and the detail. I love the temporal consistency. And look at the accuracy relative to how short the prompt is. Quite amazing. I click out. Okay, so this is great. I want to understand what else is possible from the pre-built prompts page, but for other industries. What has Microsoft made available for me? I go to the industry filter and I see industries like consumer, education, financial services, and sustainability, with more industries coming soon like media entertainment, gaming, and retail. But if I'm just a developer and I want to understand what I can do with Sora, let me check out the consumer tab and understand what's possible. I click consumer, and I'm taken to the same 3x3 grid to understand the industry prompts available. I click on the top left video and I see stunning personal memorabilia, architecture, fashion, art, and pop culture. I click out. This time I really want to see what's available for my own industry. Let's see education. Okay, I can see prompts available to me from science, art, and history. I click on the top left corner of the video and I see the Schrödinger's equation on a chalkboard. The next video is a visualization of the quantum entanglement principle. I think our student base is really going to enjoy this when they get to superposition and entanglement. And in the next video, I can see what it would mean to walk the streets of ancient Rome, helping my students empathize with past, present, and future. I click out. I'm feeling pretty confident that Sora is going to help me with my use case. So I scroll up and I click Deploy Now. I select the model, I confirm, and I'm happy with my deployment information. I selected the standard deployment type, which means I'm paying per API call. I'm happy with the resource location and capacity, and I click Deploy. And within seconds, my very first Sora API endpoint has already been provisioned for me. I'm taken to the Generation Histories tab. Nothing is there yet because I've not submitted a text prompt, but from the bottom of the screen, I can see the prompt bar with all the generation controls available to me. Let's try a prompt around the solar system. It's only 2 words. Let's see how accurate I can get it to be. I'm going to look at aspect ratio, resolution, duration. Let's increase this to 10 seconds. And let's make the number of videos that are produced from 1 to 2. I click Generate. And within 1 to 2 minutes, some movie magic applied here, but within 1 to 2 minutes, my very first Sora generation is here. This looks beautiful. It's artistically creative, though not scientifically correct. If I go to the next video, I'm very inspired with the visuals, though this tells me that prompt adherence isn't very strong right now. I need to improve this. So at the top of the lightbox effect, I click Edit Prompt. And this time, I want to make it more specific. Let's say solar system with the sun, Earth, and Mars in focus. I'm going to change, I think maybe let's do resolution to 720, and let's drop duration down from 10 to 5 seconds. I click Generate. And again, within a couple of minutes, my next generation is available to me, and it automatically opens up in Lightbox Effect. This looks good. I'm really liking the temporal consistency. I love the length of the video, and it's somewhat scientifically more correct than what I just had. I can see the sun, I can see the Earth, and I can see Mars. Okay, this is good. I'm going to download this as a reference video to a local file as an MP4. When I click the information generation tag, I can also see the edited prompt that I used, which means that the state was saved. I click out. Let's try quantum computing. How good can Sora help me out here? If I remember correctly, Microsoft made a quantum computing pre-built prompt available to me earlier. So I go back to the pre-built prompts tab, I copy the quantum computing prompt, which automatically fills the prompt bar for me. I'm not going to touch it. I click Generate. And within a couple minutes, my very first quantum computing inspired Sora generation has been created. This looks good. I can see the quantum chip, I can see the gates. Any student that's going to be covering quantum gates would understand how that's mapped to the hardware. I like this. Okay, I want to see if I can get this to be a little bit more accurate. So I'm going to copy the prompt, and this time I'm going to hit Rewrite with AI. When I hit Rewrite with AI, I'm able to enable an industry system prompt. In this case, it's education, and I'm going to say, let's include annotations and diagrams and make it a little bit more scientific. And within seconds, GPT-4o has rewritten my text prompt. I'm talking about qubits and quantum computing gates. I think that's going to make sense. I see the video, I can see some of the labeling, though I must admit the first video was probably a lot better, and that's the one that I want to port to code. So I click the code sample, and I can see multilingual code samples available to me with Entra ID and key authentication support as well. I can scroll down, I can see the headers constructed, the body with the relevant prompt and generation controls. It's contextual, so it mirrors what I just used in the playground. And when I scroll down, I can also see my API endpoint and my key. If I scroll up, I know I can change the language of the code sample: JavaScript, C#, JSON, curl, and Go. Okay, that's great. If I wanted to take this to my IDE of choice right now, it would mean maybe 5 or 6 clicks. I'm copying my code sample, I'm copying my API endpoint, and I'm also copying my key. I'm probably going to save this into a text file, but the issue with that is that I might accidentally share this to someone who doesn't have Sora API access permissions. I might share this out of the boundary of my own enterprise, breaking trust and undermining security conditions that my team has worked really hard to build. And I also might just leave the API key and endpoint in my GitHub commits. Who knows what I'm going to do? I'm fun that way. What I'm trying to get at is that there's some friction in this process. It's abstracted, it's somewhat outside of my control as a developer. I'm going back and forth between various Foundry and my IDE of choice. There's friction there, not to mention the bad practices that I'm exhibiting as an engineer. So how can I fix this? Foundry is here to help. And this week, we announced the public preview of Open in VS Code from chat and agents playgrounds within Azure AI Foundry. In one click, your agent or model API endpoint, key, and code sample from Foundry will automatically be imported into a new workspace in VS Code for the web through the Azure AI Foundry and VS Code extension. Once there, the agent or model can be run locally, and using AZD commands, you're able to add, provision, and deploy a web app that uses your agent or model. Finally, you can continue to desktop in one click, and doing so clones the workspace structure to a GitHub repo, ready for you to open in GitHub Desktop or continue development locally. Frictionless and easy, Open in VS Code is here to accelerate your developer velocity across Foundry, VS Code, and GitHub. And us as developers, we get the benefit of zero config bootstrapping. You can run code instantly without setting up environment variables, authentication headers, or endpoints. Of course, there's the benefit of secure credential injections. API keys and endpoints are pulled securely from Foundry, and I'm practicing best secret hygiene. And of course, you can stay in the flow. No more context switching between Foundry and VS Code. We talked about the planning and development stages earlier. Hopefully, this is the bridge that makes your life easier to get to code quicker. Open in VS Code will be available for images and video playground soon. It's on the roadmap, but let's see current product shape. I've adjusted some of the code to replicate the Sora API, so let's see how it would work. Okay, so I'm in my code sample, I click the Open in VS Code button, and I'm taken to VS Code for the web. I can see the environment automatically setting up, and in the bottom right of the screen, I can see the sample code downloaded successfully, and my API key is already set within my terminal's environment variables. The environment is setting up from the terminal itself, and I can see instructions on how to run the model locally, and also clone my repo and start using AZD commands as well. When I go to the environment variable file, I can see information like my subscription ID, my connection string, endpoint, also my API key, look away, it's sensitive data. But all of that was made available for me. I didn't do anything. When I look at the requirements.txt file, I can see the necessary libraries and dependencies that I would need to use straight from the Sora code sample. So you can see the right ones, and I can see my install file. So I'm just going to make sure that the install file, the bash file, is executable. I'm going to run chmod from the terminal. And then run the file, just to make sure that all my dependencies are there. When I click the run model.py file, it's the same code sample that was available to me for my Sora generation, but now automatically imported for me in VS Code for the web. So you can see my endpoint, my subscription key. You can see that I'm constructing my URL with various headers and the same body that was used earlier. In this case, I'm using the prompt called earth from space with specific generation controls. I'm building the right API with URL. I'm polling now just to make sure that the video generation is successful and I understand what's happening. I scroll down and I'm going to get a video generation job. So from the terminal, I'm going to just run the Python file. And within seconds, I've been able to construct my input for the Sora API. You can see what parameters are being submitted to the job. It's the same prompt, it's the same generation parameters, and so on. And very quickly, within a couple of seconds, the job has already started. It's queued, and now it's running. And within the same time frame that you would see in the playground, you'd be able to get your Sora generation. So if I'm able to scroll up, you can see the output that has come from the API. It hasn't failed for any reason. You can see the inputs that were accounted for, and so on. So when I'm able to dump this into my own file within the environment that I'm working in, or save it as a media file on my local development, I'd be able to get a Sora generation just like how I saw in the playground. So if I scroll up, you can see that the generation was completed and successful. Okay, so that's great. Now I want to try and spin up a web app with this model. So I'm running AZD init, and I'm cloning the repository that I was using, which is getting started with AI agents. I'm overriding it, which immediately changes the structure of the repo. So now I'm including files that will also help me build my web app, not just the files that I was using from the playground itself. I'm next running AZD up, which is provisioning the relevant Azure resources that I need to spin up the web app. And within a few minutes, I can see resources like Azure Storage and Azure Container Apps. And what it's produced is a web app URL, and if I'm able to click that from there, I'd be able to see an application that uses Sora. In this example, we're using an existing agents and chat playground, and coming soon we'd be able to make this available for models available from the image playground and video playground as well. From the bottom left corner in the screen, I'd be able to say continue to GitHub. I'd be able to sign in, and then it'll clone my entire repository structure to a GitHub repo. So I'm selecting a repository now. It's publishing to GitHub. I click open in GitHub. And within seconds, I'm taken to a repo that has cloned the exact same structure that I was just using. And if I scroll down and I see the Python file, I'd be able to see the relevant code sample that I was using for Sora, or for agents, or for models. And from there, I can continue to clone locally or open in GitHub Desktop. Open in VS Code is there to help you port from the playground into your VS Code environment. So with that in mind, that completes the inner loop when we're thinking about Foundry for the sake of multimodal development within the inner loop. As you're starting to think about agents and model chaining as a prerequisite, just like how ECW and WPP have done, what is beneficial is thinking about how you can build more resilient systems later on by preparing your organizational strategy for agents now. That will turn isolated models into adaptive stateful calls that will allow you to reach that dream of a single unified pipeline across the enterprise that's able to extract, transform, and act on a variety of different data imports across your enterprise. So to make this real, we'd love to invite Cameron Milne, Head of Growth from TPNG, a WPP company, to speak more on the application of Sora. Please welcome Cameron to the stage.
Wonderful. Thank you very much. I think I have a video to get going.
As part of WPP, TNPM is one of the world's leading full-service creative and media agencies. We aim to create customized content that often face cost and time challenges using manual production techniques. I think what's really exciting at this moment is the way in which we're using AI to create more personalized content.
We turn to Azure platform so we can use AI to bring our media solutions to the next level. We are having a robust, responsible AI safety stack.
The new video playground for Sora in Azure AI Foundry, and in particular the Azure OpenAI Sora API, is transforming the way we use generative AI tools. For larger batch work, having API access means I can take Azure OpenAI LLMs and feed them a PDF of brand guidelines and say, give me the perfect Sora prompt. Then it automatically sends that to Sora and generates the videos. API access integrates and speeds up my workflow in a way that other services just couldn't.
We had the idea to generate an original story in a comic book layout about the dog our user is adopting. Users input an image and we designed the workflow to use Azure OpenAI to generate the prompts, which are fed into the Sora API to automatically create the animation personalized to that user and their dog.
With its robust trust framework, comprehensive API, and the video playground, Sora allows us to unleash our creativity and productivity.
We're thrilled to push the boundaries of storytelling and create futuristic experiences with Sora on Microsoft Azure.
Wonderful. Fantastic. Thank you, everyone, for watching that video. What you've just seen is a snapshot of some of the incredible work that our teams have been exploring with Sora, and I'm excited to take you a little bit deeper. But first of all, hello, my name is Cameron. I'm a partner at an advertising agency called TNP. We're part of WPP, who are one of the world's largest marketing services companies. Over the last few years, we've fully embraced generative AI in almost all of our creative workflows. It's a means of unshackling human creativity for us. But it's only recently that these technologies have gone from being toys into pretty revolutionary tools for us. And we're fortunate enough to get early access to the Sora API through Azure OpenAI Service. Thank you, Microsoft. And today I'm going to show you what we've been experimenting with. Like many people, we started out by playing around, dancing, foodstuffs, puppies, running through rainbow rooms. Our team really dove in and pushed the boundaries of what was possible with Sora. But it was pretty quickly that we started asking the bigger questions of how this is going to be useful for our clients, enhancing their brands in meaningful ways. How can we create new stories or solve everyday content production needs? So our creative technologist teams, who are now actively using Sora, use it principally for two different use cases. The first, creative storytelling, using AI to using AI to bring novel creative ideas to life. And then there's more everyday use cases, using AI to simplify what we call hard-working assets, the assets that form the foundation of many brands' advertising. So let's jump into the first use case. One of our creative technologists, Dan, I imagine that's Dan on screen, is a proud rescue puppy owner, and he wanted to encourage more people to try pet adoption. Remembering what it felt like to adopt his first pup, he recalled that adopting a dog is your chance to be a hero. And an idea was born, an idea to turn every adopter into a hero in their own AI-generated comic book adventure. So all you have to do is upload a photo of yourself, your dog, and a few details of how you came to adopt your dog, and Sora will generate a dramatic rescue story for you. Here's some of our explorative output, all from Sora. And it looks pretty great. But great advertising is about more than just some nice visuals. It's about storytelling. And as anyone who's experimented with generative AI will know, it's not quite as simple as typing one prompt and pressing go and having a long narrative display presented for you. There's some human crafting to be done. Artificial intelligence needs to be combined with human intelligence. So we had to think carefully about structure and consistency. We broke our stories, our comic books, into manageable sections, a 7-box grid. We start with our scared dog scene, setting the emotion, setting the context. We then introduce the danger. That leads us into our hero moment. And this is where the hero comes in. It's your story, you the hero. From there, we added some classic comic book style sound effects, the booms, the pows, the smacks, the bangs. And then we close the story with our hero going off into the sunset with their dog. So on the right, you can see how that kind of comes to life. But let's have a look at another couple of examples in more detail. We're going to go right to left because that's the way the clicks work. So here we go. The danger is approaching. And in this instance, for a dog, there's nothing scarier than a storm. But luckily, our hero is in to save the day. Whoosh. Takes away the dog, off into the sunset for their happy life together. Thank you, Dan. Another one here, burning building. Scared dog, moving across. We start to see the danger approaching, but luckily our hero swoops in to save the day, and again, runs off into the distance. Thank you very much, Wang Xin. All of this is created through Sora, but let me show you how this is actually built and how we got a bit multimodal with it. So first, we created a script generation tool in Python. We trained it to understand what a good comic book story structure looks like and sounds like, and how to generate scripts that are consistent with comic book tone and flow for our 7-box grid. Uses enter just a few details, and the system produces a script for Sora. So we use the Sora API, hosted entirely within Microsoft Azure infrastructure, to convert this script into the 7 videos that you saw inputted into the 7-box grid. And here's how we got multimodal with it. We added an important quality control using GPT-4o in 2 places. First, we had it double check the prompt before it went into Sora, making sure that the prompt matched the style, the tone, the format. And then once the video was created, we checked once again, reverse check in some ways, comparing to the original intent, but also flagging anything that looks off or strayed into brand unsafe video. So let's move on to our second use case. This one's all about using AI for everyday creative production. The target here is to save time and money and allow our creative people to focus on more conceptual and strategic initiatives. So we're going to call this use case the meal machine. And in the world of consumer packaged goods, in the world of food consumer packaged goods, think rice packs, sauces, ready meals, plated meal shots are the backbone of advertising content. But to date, this process of churning out plated meal shots has been entirely manual, despite the output really being quite functional. So our latest project with Sora pushed us into new territory. We wanted to automate the production of these pretty foundational assets. So a creative technologist in our team trained a large language model using PDFs and recipes, and he built a prompt engine, which you can see playing out here. It's a tool that lets you input the name of a dish, choose the location or the setting, the camera angle, a few creative choices there, and then you can select some video production specs like resolution, duration, aspect ratio, tinker with some processing information before, boom. The prompt text on the left was automatically generated by our model based on the supplied input information. Each prompt, as you can see, is several thousand characters long. It would take a human a few hours to write in this level of precision, but our prompt engine did this in just a few seconds. And the output is pretty magic. What you're seeing here is completely AI generated through Sora from a variety of these prompts. This automation frees up our teams from previously time-consuming everyday productions, like these plated meal shots. And instead, they get to focus on the more conceptual things, like comic book stories about dogs. And here are some more examples showing a wide range of different meal occasions, different meal types, settings, sometimes including humans. Now, by accessing Sora through Azure infrastructure, our creative teams and our brand clients, our partners, can be confident in the enterprise-grade security, compliance, and safety that's all built in. We can all rest easy that the output is going to adhere to a range of guardrails and governance protocols, allowing us to focus on the creative rather than making sure it's fit to go live. So I really do believe that we are in the midst of a new creative revolution. Both of the projects I showed here combined creativity with technology. A technology that is scalable and compliant, that empowers our teams to creatively innovate while maintaining the trust of our clients and, of course, our audiences and consumers. We're incredibly proud of this work, and it shows what's possible when you bring together the best of creative minds and AI engineering. So I hope you are entertained by that content as much as we were by making it. Thanks.
Awesome. Thanks, Ben, for the amazing presentation. This is essentially, in a nutshell, what we shared today. We talked about the incredible multimodal models available on Foundry, like GPT Image 1, Stable Diffusion 3.5 Large, and Sora, of course. Available now is part of our API. Specifically with Sora, it's a unique API offering, just available for Foundry users. We're so excited to see how you're going to be using this by embedding it into your application after you've had the chance to experiment with it in Foundry and also port to VS Code. We also saw a great example in how Hilo was using transcription models to result in better patient care and streamlining their operations. We saw how Foundry can help you accelerate your inner development loop when it comes to planning, experimentation, and portability to code. And we wrapped with a great example of how WPP have been using the creativity of Sora to reinvent wonderful storytelling. In terms of next steps, you can start building with image and video generation models. Make sure that you're exploring what Foundry has to offer in terms of the models, the playground, open in VS Code, and of course leveraging the APIs for your architecture available through the Foundry SDK with more documentation available to help your needs. We'd also love to hear your feedback as developers on what's working and what we can keep improving in as well. Let's please keep discussing with us your feedback, and let's keep the conversation going. Most of the sessions from the week have been recorded, so please do check them out online. And feel free to reach out to the speakers on LinkedIn or through the Foundry Discord channel. We'd love to keep understanding how we can help you. Thanks so much for the session. Have a great night.